We have all looked at this graph before. Sorry. P of x and Q of x are polynomials, is basically what this is talking about. And a polynomials we're looking at could be a whole bunch of string of stuff together. It could be a constant over an over a binomial, something along those lines. And like I was saying, the most common one that we start all of these graphs to look like looks like 1 over x. If I look at that graph, P of x over Q of x, they're both polynomials. When I look at this graph, what can't x be? Can't be 0. I thought you said it. It can't be 0. If x is 0, I'm divided by 0, and what happens? Bad things. We win a door decorating competition.
That's not a bad.
That's good.
It's a good thing. So what happens here on a graph, you get something that is called an asymptote.
I'm pretty sure.
You get an asymptote. You get an asymptote. An asymptote is something that you are approaching, but you never exactly get to. It's like you can always take half of a number, but you're never going to get to 0. Have you ever ridden in the bless you? Have you ever ridden in the back seat of a car with your little brother, little sister? Go, I'm not touching you. I'm not touching you. I'm not touching you. I'm not touching you. And your parents want to smack you? Sure.
Actually, I don't have any.
I didn't talk until the age of 10.
Now you won't stop. The asymptote, it's something that you're approaching, but you're never going to reach. Okay? You're never going to get there. These functions are going to have vertical and horizontal asymptotes. I'm going to show you guys how we find them. Vertical asymptotes are always going to be found at the zeros of your denominator, because we're looking at fractions here, because you can't divide by a 0. So if you had something that looked like this, 1 over x minus 4, what would be your 0? It'd be at 4. So where would your asymptote be at?
1, 4.
No.
0.
No.
4.
4. There's our charm.
You said 0.
A vertical asymptote, your vertical asymptote is always going to be x equals some number. Okay? It's always x equals some number, and that number is going to be the 0 of your denominator. Yeah?
What did you say that was
Asymptote.
what was the definition?
An asymptote is where a graph is approaching, but it's never going to get to. And I'll show you this, how this looks when we're looking at the graph of 1 over x. When you guys have always graphed stuff, you've always started by making tables. So if x is 1, what's y?
Oh, fun. So easy.
Wow.
If x is 2, what's y?
1 half.
1 half.
Oh, so it gets.
If x is 1 half, what's y?
1 4.
Check it again.
Check. Linearly smaller.
It's 2.
Oh.
1 divided by a half is 2.
So it goes down and then up.
You get a curve that looks like this.
So
No, he went backwards.
Oh, he
We were
went
going
back.
that way, and then he picked the point.
Okay? You get a curve that looks like that. It's as x is getting larger and larger and larger, you're getting a smaller and smaller fraction. As the fractions get larger and larger, or fractions get smaller and smaller and smaller, the y gets bigger and bigger and bigger. What's that? It is. It's a lazy parabola. And that's what kind of what you think about it. It's a parabola tilted on its side. Yeah. I just picked easy numbers. If x is 1, y is 1. If x is 2, y is 1 half. If x is 1 half, y is 2. I just picked quick, easy numbers to work with. And then I do the same thing with negative values. If x is negative 1, what's y?
Negative 1.
Negative 1. If x is negative 2, it's at negative half. If x is at a half, or negative half, it's at negative 2. And you get the same idea. You get that. And like Leaf was saying, it looks kind of like a parabola that fell over. Okay? And all of our graphs are going to have some sort of a pattern to this, except we're going to have a little bit of a shift.
So the part that doesn't meet, is it supposed to be like the part where they're like this?
Yeah.
That's the part that gets the closest.
Yeah. So you're going to wind up with stuff that looks like this. Y equals A over X minus H plus K. Well, we're going to get this generic look.
A, H, and K.
Again, A, H, and K. Where your values of your vertical asymptote is at X equals H, and your horizontal asymptote is going to be at Y equals K. And again, A, H, and K. And you're going to find that plotting and graphing these are going to be really, really easy because there's just a couple of steps to them. Again, when I have a problem, y equals -2 over x plus 3, subtract 1. When I get that equation written in that form, the very first thing I always do is label what is h, or a, h, and k. So if I look at this example here, what's my value of a?
-2.
What's h?
Say
-3, good. I knew that one came from you. And then what's k? -1. Now, if you look at your h value, see how your h value is -3? Isn't that the 0 of that,
Yeah.
of x plus 3? -3 makes that 0, doesn't it?
Yeah.
So remember, your vertical asymptote's always going to be at the 0 of a denominator. Always, always, always. Again, when I go to graph this then, oh, I should get you some graph paper. First step I'm going to do, we did that -2, -3, -1, is get some graph paper.
Is that a synonym?
Take 2 sheets, because you'll do one with notes and then one for homework.
If you're out, how much fun
I don't. I don't have it.
Probably does.
No,
I'm surprised you guys aren't wrapping this thing up in graph paper. That would have been a great idea.
Alright, so homework was a bad idea, but graphic paper is just great.
Yeah, graphics don't need to trade it out.
Oh, that would be good actually. We can put it
Where's
over
the
that.
outlet?
Okay, ball. Really well.
Right in the middle of the.
Oh, I see it, okay.
We can,
Okay.
we can actually do that. Big graphing paper over this so it's magic graphing paper that lights up.
Like an Etch-a-Sketch?
No, that's what we
Or
should
light
do.
bright.
Oh, like
You
a.
need to stick the lights through it.
Yeah.
And like, be like the point.
Make
Wouldn't that be like kind of like a fire hazard? Oh wait, it's gonna be a fire hazard anyway. We've got 1,000 lights going up on the street, or on this door.
What if it did?
The email I sent to Mrs. Roper about looking for tape, I said, I'm sorry if I blow a fuse. Just put that out there. We'll see what happens.
Crazy.
I know. All right, so again, we start with the function that we're given here, this weird-looking rational thing that we're going to graph. We know that our vertical asymptote is going to be at x equals -3, because that's the 0 of the denominator. So what I do is I start by plotting that. -3.
Solid.
If they're dotted. Asymptotes are always dotted because you're always approaching them, but you're never going to reach them. I've plotted my vertical asymptote. Then I go and I figure out my horizontal asymptote is going to be at y equals -1 because that was my k value. And I plot that. Everybody with me so far?
Yeah.
Okay. Now, in order to figure out how these curves are going to look, these lazy parabolas, as he put, is that I'm going to take 2 ordered pairs to the left of the asymptote and 2 ordered pairs to the right of the asymptote. So if my vertical asymptote is at -3, what are the next numbers to the left of it? -4 and -5. And I'm going to substitute into the equation -4 and -5 to figure out what the y values are. So, let's do this on a second sheet. I have -2 over -4 plus 3 minus 1. Well, what's -4 and 3?
1 negative
-1. What's -2 divided by -1?
2.
2. What's 2 minus 1?
3. Oh. No, I thought it was negative.
So at -4, it's at 1. I do the same thing with -5. -2 divided by -2. 1. 1 minus 1 is 0. So we go back to the single here to graph it. So at -4, it was at 1. At -5, it's at 0. By plotting those 2 points, can we tell the direction of this curve now?
Yes.
What's it doing?
Oh.
Oh, but I'll buy that. It's doing that. That's one half of the graph. Yes, ma'am?
So how did you figure out the -4, -5?
We knew that the vertical asymptote was at -3, so I take the next two numbers to the left of it, and then I'm going to take the next two numbers to the right of it for the other side. So if my vertical asymptote is at -3, the next numbers would be -2 and -1, and I do the exact same thing I just did here by substituting into the value. Does that make sense?
Do we have to, since you know the curve?
Well, you know where the curves go, but I still need to know where my points are. The requirement that I have for the graphing is this: asymptotes and 2 points. That's all I'm asking you guys to do. All right? -2 divided by -2 plus 3 minus 1. Again, we have -2 divided by 1. Minus 1 gives me -3. And then if I do -2 over -2, -2 I believe. -2 divided by +2 gives me -1. -1 minus 1 is -2. So now I have my other set of ordered pairs. So at -2 is -3. And this one's going like this. And there's your curve.
You get it real closely.
How did it?
And it's not going to look perfect. It really won't. And if your graphs, when you draw on your sketch, if it runs into your asymptote, is it that big of a deal? No. I know, asymptote's a funny word.
It is.
It is.
It really is.
So, all you have to be able to do with these things, again, label out where your asymptotes are, pick 2 points to the left of the asymptote, 2 points to the right of the asymptote, and label them. It's very straightforward. Yes, sir?
Are they always, how do you say it?
Symmetrical?
Symmetrical.
They are. And they will be symmetrical. And there is in here, believe it or not, a slant asymptote
Of that third dimension, huh?
that we don't really deal with in this class. There will be a slant asymptote. We'll worry about that at some other point in time. Okay? But they are symmetrical. They do fold over on each other across the asymptotes like that diagonally. Okay? Oh, I need an autograph.
Oh, who is that?
Take that off. Take
No.
that off. Take that off.
That's the face of a warrior. You're fighting for victory.
Is that Derek Rose?
That's Victory Husky.
You're killing me.
I'm killing you.
You're killing me.
Small.
You're good. Correct.
It's
Right.
still Brittany.
Now it's like a triple
Can you
H.
put-
Can you like switch the R and the T so
Right.
Ricky Martin?
Pat, Pat Irk.
I like it.
Brittany, that signature isn't much of a signature.
Shut up.
It's more of a, let me print my name quick.
Hey, at least she's cool enough to get in the newspaper.
Oh, that's why I run.
Well,
There you go.
Now, there's the other guy was saying there's another style of the graph that we're going to look at today as well. One that we have the AH and K, and then this one that doesn't have AH and K in it. This one looks more like AX plus B over CX plus D. Yes, sir.
I have faith that Hunter can get into the newspaper with his philanthropy work.
Good luck, Hunter. Anyway, can you tell the big difference between?
I'm Lothario.
Can you tell the difference between these two generic functions of why you would choose one over the other? What is the big difference between these two? The AH and K one and the one without.
Polynomials.
D and D.
Oh yeah, there's a big D and a D here. There is a big deal.
It's okay, and
That is a pretty big deal.
See how there's X's in both numerator and denominator?
Oh, so
That's why we have to have two different types. So in this case here, since there are X's in both the numerator and denominator, we can't use the one on the left. This one actually is a little bit easier to work with, believe it or not. When you have a generic function, let's say it's y equals 2x minus 1 over 4x plus 3. Let's say I'm looking at that example. And I want to identify, first thing we want to do is identify our horizontal and our vertical asymptotes. My vertical asymptote is still occurring at the 0 of the denominator. My vertical asymptote is at the 0 of the denominator.
Oh, that's
So here it's going to be at 4x plus 3 equals 0. So where's that 0 at? Negative 3/4. My horizontal asymptote is a little bit different now. In order to figure out my horizontal asymptote, I take the coefficients in front of the x values and divide them. So it's going to be at y equals 2 over 4, which is 1/2. So my horizontal and my vertical asymptotes, I still identify them first. Okay, I'll split the screen here so I get a piece of graph on. So if I have a vertical asymptote at, oops, blow this up a little bit for you. If I have a vertical asymptote at negative 3/4, it's close enough. I have a horizontal asymptote at 1/2. They are. Squint a little bit more, they are. And then again, in order to figure out the ordered pairs. Oh, okay. Again, in order to figure out ordered pairs here, I pick two numbers that are to the right of the asymptote, two numbers to the left of the asymptote, and I follow through the exact same pattern. The idea, again, your vertical asymptote for these the horizontal asymptote is the coefficients. Again, once you figure out the vertical asymptote, take 2 points to the right, substitute in. Take 2 points to the left, substitute in. Those are your ordered pairs. Now, granted, in this example, it's going to be some really nasty looking fractions, but it's really not the end of the world. I have an example that's a little bit easier to work with. We'll walk through that one.
Ooh, Brittany.
I get another autograph.
Are you dunking in that picture?
It's gonna go all of you soon. You have more. You're getting more pictures in the paper than like the Venuses.
You like
Maybe
cover
a
my
6-foot rim.
Brittany, can you please spell your last name P-A-R-T-I-C-K?
Could you spell your first name right instead of Brittany?
Just throw something in.
Look at that. Thank you.
Oh, I like that.
Could you die
Alright,
right?
P-A-R-T-I-C-K.
Oh.
Oh, come on.
Patrol.
Please stop.
Brittany Patrol.
Let's look at this one. I have y equals x plus 1 over 2x minus 4.
He said not to use the dirty
And again, I'm going to go ahead and state out my domain and range. Remember, your domain and range, domain's going to be all of your x values. Your range is going to be your y values.
And why do
But be careful when you're talking about domain and range with these things because you have asymptotes. That just means that that's going to be the ones that you can't have.
I'll
So
never hit that.
again, when we start with y equals x plus 1 over 2x minus 4, I'm going to find my vertical asymptote to start with.
2x minus 4.
So what's the 0?
2.
What's the 0 for the denominator?
No.
Everybody agree it's 2?
Close.
Okay. My horizontal asymptote is going to be at what?
Oh,
What else?
it's going to be at 1/1/2.
Is it positive 1/2 or negative 1/2?
Positive.
Positive 1/2. 1 over 2. Those are my asymptotes. Okay. So I start by plotting out the asymptotes. X equals 2. Y equals 1/2. And yeah, it's 1/2 because it's x over 2x, so the coefficient of the numerator was 1. Okay? Now, yes, sir. I set this equal to 0. 2x minus 4, you get 0. I get 2x is 4, x is 2. That means my vertical asymptote is at 2. And then my horizontal asymptote is the coefficients in front of the x as a fraction. 1 and 2, 1/2. Okay? And then lastly, you pick out points. If your vertical asymptote is at 2, you have two numbers to the right, 3 and 4. Two numbers to the left, 1, 0. Substitute in those values, and you're going to get your ordered pairs to plot. So you guys do 3, you guys do 4, you guys do 1, and you guys do 0. We just cut
What are we
our
supposed to do?
3.
Oh,
We're cutting our workload down so we can talk about the door.
I already did 1. No, guys, can we do 1?
Yeah, we'll do one.
We'll do
We
1.
have it done.
It's
Start-
negative 1.
It's already done.
Or your...
Alright.
What'd you get? What do you guys have?
3
Five
and
and 4?
2.
3 and 2.
You guys had 2? Did you guys get for 1?
0 is negative 1/4.
And what'd you guys get?
You're disgusting.
For what?
It's going to be 1/4, I'm guessing, for 4.
Once again, I mean, you can have passes now.
Okay. What'd you get for 1?
Negative 1?
Is it negative 1? Thanks for not being in the row.
I did it.
What'd you get? Negative 1?
I got negative 1.
Then you just plot those 4 points.
The other one's 5 over 2.
That's okay. So at 3, 2, 5/4. That's 1 and a 4th, right? So about here. So it's doing the curve this way.
Wait, I'm really... How is 4 5 over 2?
At 1, it's negative 1. At 0, it's negative 1/4. And it's going this way.
It's 5 over 4, not 5 over 2.
So if I'm looking at this now for the last bit, if I want to state out my domain and range, remember my domain goes with my x values. What can't x equal in this problem?
0.
Where is your horizontal or your vertical asymptote?
Negative, no.
Where's your asymptote?
1/2 and 2, 2 and 1/2. 1/2, comma 2. I can't.
Hold on. Where we're talking about your domain, you're looking at your x values. Where can't x, what can't x equal? 2. So my domain is going to be all numbers except 2. What I'm doing here by stating my domain and range, I'm stating all the values except where your asymptote is. Yeah. Question.
Larger and smaller than, greater and less than
You
2.
can, but it's
That's
it means the same thing.
That equals
And then the same thing for your range. What is it going to be work for your range? Yes.
How did you figure out the second of points? Like, what did you?
Wherever you know where your vertical asymptote is, just take 2 numbers to the right of it, 2 numbers to the left.
Yeah,
It's
yeah.
arbitrary.
Then once you find the, how did you find the negative one?
What's 1 plus 1? What's 2 times 1? What's 2 minus 4? So you have 2 divided by negative 2.
Okay.
I'm just plugging and chugging. Okay? And then again, the range is all y not equal to 1/2. Every one of these problems, you get the same idea. Find your asymptotes, clap a little bit, pick 2 points to the left, 2 points to the right of the vertical asymptote, look the way the curve's going, state your domain and range. That's all there is. Okay? I want you guys to do a couple of these tonight. I have no more pictures, it's okay. Work on those. Again, you need domain, range, those 4 points, and go from there. All right? If one of you guys, after you write that down, wants to run and get the tape out of my mailbox.
Vince, can else we go? Vince,
I got
we were
it.
going the first time.
Well, you don't need like 3 people to go.
But we
Just
did.
one person that's fast.
Richie's so quick, you don't get it.
I don't know where your mailbox is.
God, you guys kill me.